Example 5 asks us which of these three graphs is the graph of y equals 1/5 x shifted 1 unit to the right. And to approach this problem, we're going to look at those key points from yesterday. The normal graph, if it wasn't shifted at all, would go through the points 0, 1. And because this is decay, I would look for a negative 1x value and take the reciprocal of that base being 5. And I'm looking for which one of these three graphs is these points shifted 1 unit to the right. And so first off, this choice doesn't even make sense because that's a growth graph. So we're down in between these two. And I'm noticing that this graph goes through 1, 1 and 0, 5, which to me seems like the 2 points 0, 1 shifted 1 to the right and negative 1, 5 shifted 1 to the right. Whereas this graph goes through 2.5 and 5. Oh, that's what I wanted to mention. When I show you guys these types of graphs, the 2 points I will always show you are the points that would have been 0, 1 and the other point that's based off of the base. So every time you guys see these types of graphs, look for those 2 key points and try to determine where they moved. The point that's further away from the asymptote is the one that we got from using the base, and the point that's closer to the asymptote is going to be the one that would have been 0, 1. Sometimes I'll show an additional point down here, just like because I have old worksheets that do that, but you don't need to worry about the point that's like clearly a fractional value. So, knowing that this would go through 0, 1 and negative 1, 5, and this graph seems to have those 2 points shifted over, this is the graph I would select. As far as the domain and range goes, the nice thing about these, like the domain, it's always all real numbers. Now the reason is because if I go to the right and I go to the left, even though this looks like it kind of like doesn't ever go past negative 1, these graphs do continue to go to the left or the right forever. There's an arrow at the end of this. So there's an arrow at the end of this x-axis. And down here, it's going to the right forever as well. So this will eventually cover the entire x-axis. That domain is going to be all real numbers. As far as the range is concerned, I'll do a similar motion. I'll go up and down. As I go up and I hit this arrow, that means the graph goes up and continues to go up. Now as I go down, we do have this asymptote, which is a boundary line the graph never quite reaches, right? It never goes below it, never quite reaches it. So even though there's an arrow going down, there's this invisible boundary line called an asymptote that happens at y equals 0. All the y values are definitely above 0, but the graph never reaches 0. So my range is y is more than 0. And then the equation of the asymptote is going to be this horizontal line where every single y value on that line is 0. So it's going to be y equals 0 for that as well. As we do a few more of these examples and I kind of clear up these points, it'll make more sense. So let's carry on and see what happens next.